to the channel, and in this very section I will be showing you how you can basically create a linked list and perform some of the various operations you have on your regular arrays on linked list. And if you missed the first section of this series, you can do well to check that on the link description below, where I discuss on some of the benefit of arrays and lists and memory management, where I made explanation of if you are working with any of the high level programming language like JavaScript, Python, and Java and all of that, and you don't get to access the memory of your data, except that is being handled for you for some um, security reason and then for your own profitability, I believe. So I want to show you how linked lists work in this part of the section. If you want to get the introduction, you can do it to check that as well. So now linked list, whenever you think about linked list, you basically have to have the assumption of working with two blocks majorly, unlike an array, just like I explained earlier on, where you have the block of your items being stacked next to each other. But linked list doesn't happen that way. All right, now linked list use what we call pointer to point to the next item on the list, and if you are on the last item, that will point to null. Now every linked list usually have two blocks. I want you to always picture that, and just like I have it here, I think let me move let me demo that with the arrow. Oh boy. Okay, so now I just wanted to picture this as your node, right? So it's basically a collection of node. Every item on the list is likened to be a node, and within the node, the first block can contain your value, and then the next block will hold the address of the next item on the list. Now, take for instance, if you take a look at the items we have in the array right in here, I want to assume this to be a list. So now the first block will hold this value 12, and then the other block, just like I have here, will hold the address of the next item to the list. So whenever you need access to that, then this can point to that next item on the list. So it happens this way. If I'm to put that in a pictorial view of how that happens, now here we have, this is the node. Let me get that once again. Okay, all right, let me have it here. And this can be anywhere on your memory space, maybe somewhere here. Now what will happen is, within this, I want to assume this, the address to be of this to be number maybe XHA12 maybe, right? And then here we'll have number 12, and then here the address will be the value we'll have in here, which is XHA12. All right, so now that is in a nutshell what you'll be having. Now if I'm to have that in a pictorial representation of that, this is what exactly we will have on our system. All right, so now, and remember here we'll have the value of 13, and now 13 will also hold two blocks, and the next block here will hold the value of the next item on the list, which is the value 1, and that is basically how your list work. Okay, now what let me have this duplicated again, and I'll have this here, and I may duplicate my arrow symbol. This can point here, and this one will come exactly right here. I think we are done with this. Let me take that out. So now this is pointing here. Now within here we can have the value of 13, and the next item there will be the address to this next item where this is pointing to. Maybe that should be XAB23. Okay, and then this can be the last item on the list. All right, so we'll have I just want to end there. This will point to null. All right, and then here we'll have the value which is supposed to be there, which is 1. So now that is one of the very basic thing about linked list. All right, now if you want to add more item, all you need to do, which I will show you very shortly on the code snippet, is to let me have another item here. Maybe we want to add the value 4 this time around, and 4 can be anywhere. 4 can be anywhere on the system. I think I can brag this here, and this can come in here. You can see how they are randomly placed on the screen. All right, so now here will contain the address of XC21. All right, and maybe that should be the address of 4. Okay, so let me put 4 here, which is the next item after 1, and then for now 15 is not linked, so the address will be 0, and here I have the value of 15 now, and this address is maybe XV11, XB11. All right, and that is the address of this 15 right in here. I can have this is pointing to this list right here. Okay, we have that pointing there, and these can finally point in here, and oh, okay. All right, so this is in a sketchy format. This is how our items, get placed or linked to other. All right, so it's a list that are linked together. I believe maybe that's where the name linked list come from. So that is how linked lists work. Now, if you want to add an item, all you need to do, if you want to append or add an item to the end of the list, all you need to do is to change the address of the last item here to point to that next item, just like the way you saw me, adding more item and on like that. Now, one of the easiest things for you to work with linked list is once you're able to identify the head, okay, and that is how you get to add an item and locate every part of the list. Okay, now if you want to remove the last item, maybe all you need to do is to set the address of the second to last item to null, and what you're doing indirectly is you are removing this last item, and that is how you remove an item you remove an item at the end of the list. Okay, now what if you want to remove all items from the list? Okay, all you need to do is to set the head to null, and every of the list will get disconnected. You can see this is like an O of 1. Okay, if you want to remove all of the item within the list. So, and that is one of the basic way you can have your list and have it created. Okay, now just like I explained in the previous series, if you want to get the address of your variable within your code snippet, you can just try that out with this C file which I created, and you can use the ampersand. This symbol allows you to access or view the address of where this item is being stored, and you have to compile this. You have to have GCC compiler on your Mac, Linux, or Windows system. I have that installed on my system, and that is why I can compile this code. I can run gcc-o, that's the output. I want the output to be result, and then I want the result, that's the output, and what file do I want to compile? I want to compile my address.c. Okay, now if I run the command snippet directly of if I try to run the result, and I get to see the address of just both letters A and B, and you can see here that they get randomly place, despite the fact that A comes and then B next. You can see from the address printed right here, they are not coming stacked next to each other. So that is one of the things, and that is one of the benefits of using linked list, right? Because of the space. Now, if you're working with an array and maybe you have some space, but you don't have a block of, an integer have on 32-bit system have 4 bytes. Now, if you have some, space that are not connected, if you want to stay from array there, you run into out of space memory. And if you have a list, list can help you manage that, and then they can randomly, just like we have it here, randomly place the item. But remember, linked list will consume more memory, right? Because you're not just getting a space for just the 4 byte, you also need a space for the address on each of the node or each of the list. Okay, now let's just create a basic linked list, and let me call it linked list.js. All right, the concept is basically the same in every stack or every programming language you're working with. The concept, the logic behind it is very much the same. Now, the only thing is you might actually have to, if you're in Java, you have to use your static type to write your code, or if you're in C, C Sharp, or any of the programming language, you want to practice this along with me. So now I said the basic thing in a linked list is the node, which is the block we have right in here. All right, so now we're going to make a class, and we'll have a class of 2 items, which we have the head, or you can call it the element itself, and then the address, or we can call that the next. All right, so let me create a class. I can call this node, you can call this list, but I would love to call it node. I have a class and I'll call it node, and I have my class right here. Oh, this class, my typo right there. So I'll call that a class, and then within my constructor of this class, right, I want to require, for the very beginning, I want to have just the element. All right, and then within the constructor, I can, assign my variable. So I want to have this dot element equal the element, and then I want to have my this dot next. I want to set that to null. All right, because from the very basic beginning, each list have the element, and then the address is pointing to null. Now the address will point to something if you add that, and so we are basically just creating the head, or just a basic node, right? So it's basically just the node first, and then the address, which on the very basics is a null value. Okay, so now this is a very basic node I'm having right here. Now I just want to create a very basic list first before we talk about some of the functions, some of the method, how we can add, how we can link other items all together. Now let me create a basic linked list of let's list equal, let me instantiate my new node. Let me create an instance of that. I want to create an object from that new node of 1. Okay, now I want to print my list. So if I go ahead and log, if I console log my list, and let me pull up my Coca, and so we'll see the result. Okay, so now this is my basic list. I have the element, which is 1, and then the next for now is pointing to null. All right, now what if I want to add, just like this very basic one here? All right, this arrow for now is not pointing anywhere. And then if I want to add more items like this, all I need to do is to say, I can go ahead and say list.next. All right, list.next. I want to add new items this time around. If I want to add, okay, let me follow what we have here. We have 12 as the first item, so I have 12. Now the next item I want to add, which is 13. I can go ahead and say new node once again. New node of 13. Okay, yeah, so that is me adding these next nodes. Now if I want to add the third item, now if you can see on the printed console here, I have the first item. The next, you can see this is holding or pointing to another node, which is the address here, and now within that next I have 13, which is the next element, and for now 13 is not pointing to any other element, so the address is now null. Okay, now what if I want to add the next item on the list, which is 1 and then 4? I just want to have what we have in here. Then all you need to do is to have list.next. Right now, this next is pointing to the second one, which is 13. Now, if you take a look at, let me comment this out first. If I have dot next once again, and I want to call that to be new node of 1 this time around. And now that is how the chain keeps on going. Next. Now if I want to add the fourth and the last item on the chain, I have new node next again, right? This is like next equal that is not an object. I want to have that to be equal new node of 4. Okay, now you can see this is the linking of the list, right? So that we have one, and that is pointing to the next, and we'll have it all there, gets attached next to each other. So this is the very, very basic way of you having your linked list and linking different nodes together. All right, and you can see this can be somehow quite complicated, and imagine you want to add 20 item on the list, or 100 or 1,000 item. You need to have all of the next, and you can even miss one of the next, and that can make you to instead of maybe you made a mistake of your next, and instead of this to point to the next, you might actually make a mistake of this instead of pointing to that element on the list, and you can make a mistake of pointing this here. And what that means is you've automatically cut this off from the list, and maybe that is what you want to avoid. And for us to avoid this kind of complex scenario or mistake, we'll be creating a class, right, where we can have our instance of this new node in it. And if we want to get the next, we'll write some methods or function to do that, where we will be writing all of this function, right? We can have that class will have a method in there where we can find a list, we can insert, we can display everything from a list, and we don't want to have this kind of complicated next element next and all of those text in there. We can write a function that will filter out just the element. We're not interested in getting the next, all of that. And if it's the next item, the next is null, we also don't want to print that out. So I will have that demoed in the next section of the video of the series, and I will see you there. Thank you very much for sticking around. Please do feel free to like the video, comment, and subscribe, and share this on your social media channel as well. Thank you, and I'll see you in the next video section.